All right, I wanted to go over this because this is going to be on the quick quiz, okay? All right, so when you're filling out these table, we're looking at the deltas, which means change in, okay, time and position, all right? So each of these intervals is going to have a time change of 1 second, okay? And then here, 18 to 6, right, is a delta x of 12. 38 to 18 is a delta x of 20. 66 minus 38 is 28. Oops, don't need that many zeros. Okay, and so on. 36, 44, and 52. Okay? All right. So these values here represent the change in position in that interval. All right? So if I take this change in position in this time, right, then I know that in this interval, the average velocity is 12 centimeters per second. Okay, in this interval, the average velocity is 20 centimeters per second, and so on, right? So 28, because it's 28 centimeters in 1 second, 36 in 1 second, etc. All right? So these values together here are telling me the average velocity in that interval, okay? So for example, in the interval from 5 to 6 seconds, I know it went 52 centimeters in that second, so that would mean my average velocity in that second would be 52 centimeters per second. Okay? All right. So within an interval, that's my dog, sorry. Within an interval, say 0 to 1 seconds, the average velocity is 12 centimeters per second. But that doesn't mean it's going that the whole time, right? It's only going that amount on average, okay? So at the beginning of the interval, it would be going slower than that, and at the end of the interval, it would be going faster than that, so that it averages out to 12 centimeters per second, all right? So what we learned in the last worksheet was the average velocity in a time interval is equal to the instantaneous velocity at the middle time of that interval. That's what you're going to need to be able to explain, okay? So for example, in the interval 3 to 4 seconds, I know the average speed in that interval is 36 centimeters per second, right? Because it's 36 centimeters in 1 second. So the average speed in that interval is 36 centimeters per second, all right? So if I think instantaneously, that average velocity is going to happen at the middle time of that interval. Okay, that's how I can figure out some things that I can put on my position graph. Okay, on my velocity graph. Okay, so this is going to be 20, 28, 36, 44, and 52. Okay, so that's the important part. The average velocity in an interval, right, that I get from here becomes the instantaneous velocity at the middle time of that interval. Okay? All right, so when you go to graph this, I'm just going to graph it really roughly, okay, because, I don't have time for this, okay? And then it's going to go up to, 200, so I don't know, what was this, 10, 20, 30, I don't think this is going to fit, but you can get the idea. 50, 60, oh, no, it only goes up to here because it's a velocity graph, okay? So velocity graph and time, okay? So if I graph these points here in this area, okay, that's going to give me a velocity versus time graph, okay? So I want to go at half a second, like it was at 12, 1.5 was 20, 2.5, 28, 3.5, 36, 4.5, whatever, blah, 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 blah. Okay, and it's going to make a line, okay? And I can continue that line till I find the y-intercept, okay? So this data here, right, is telling me every time I go over by 1 second, my velocity is going up by 8 centimeters per second, right? So you can see here when I count this, 12, another second later, it's 8 more, another second later, 8 more, another second later, 8 more, all right? So this slope then becomes 8 centimeters per second every second. Okay, so for every 1 second that passes, the velocity increases by 8 centimeters per second. Okay, and that is what we call acceleration. Okay, that change in velocity over time. Change in velocity over time is what we call acceleration. Okay, you can extrapolate this for other data that you don't have, right? So I could say, like, if I went like 2 seconds, I would go up in velocity by 16 centimeters per second. If I went half a second, I would go up by 4 centimeters per second, right? So that ratio is always the same, okay? If I went, let's say, 4 seconds, I would have to go up by 32 centimeters per second because that ratio is always going to be 8, okay? And that's what we figured out in these tables, okay? That ratio is always the same, which is what makes this a line, all right? Okay, and the last thing, when you extrapolate back, you might want to know your initial velocity, right? So at half a second, if I'm going 12 centimeters per second, and I only back up by half a second, I'm going to back up by 4 centimeters per second, right? Because it's 8 in 1 second. Okay, so that's going to get me to 8 centimeters per second for my initial velocity, okay? Which is a little confusing, I know, because it's the same number as this, all right? So for the quick quiz, make sure that you understand this table and how it was created, because I'm going to ask you that, okay? And be able to graph this and explain what this graph is telling.